so the rocket we're going to build is based on a design I've used many times in the past. This is the overall layout of the actual rocket itself. You have the fin section, which will house the motor. You have the main body. You have the payload bay there, and there's a payload which is attached to the nose cone. There'll be a little recovery system there which constitutes a parachute. Overall length about 90 centimeters. Launch weight anywhere between 180 to 250 grams. And the suitable motor for this is S-E or an S-F. Essentially, this rocket comes in two pieces. First piece is the main body and the sleeve. The sleeve houses the payload bay. The second part of this rocket is actually the payload bay itself. Once we have all dimensions settled on, we will compute the center of pressure, which from experience with this design is somewhere about there. Once we know exactly where the center of pressure is, we'll be able to balance the rocket accordingly such that the center of gravity is at least one diameter's length in front of it. That'll provide for a stable flight. The rocket is shown as being just one single piece of tube with the sleeve covering on top there. The tube's going to be made of several sections of aluminium cans or energy drink cans. I find them very strong, very lightweight, at the same time easy to obtain. Obtaining cardboard which is of the right length at the right stiffness is somewhat challenging, or you have to order it from specialty stores, which will cost a lot of money. So I'll show you how you can still obtain the same effect for a much cheaper price. The only two things we need to purchase for this project will be the recovery system, which is a parachute, and the motor itself. We will not be building the motor. We'll be buying the motor from a hobby store and then mounting it onto the end of the rocket itself. The motor itself has an ejection charge, so after a certain burn time, there'll be an explosive charge which will punch through, and that'll push the recovery system and the payload bay out. The payload bay can have ballast, but anytime you launch a rocket, it's advised you to have something useful in it so you can conduct some experiments, albeit a homemade altimeter or any sort of experiment which will help you take some measurements along the way up.
So I'm using the program OpenRocket. I've opened up the previous design from earlier models. I'm going to stick with the same fin dimensions, same tube thickness, and I've modified the length to be 85 centimeters in total, yielding a center of pressure of 68.4 centimeters from the nose tip. In this case here, the nose cone is 11 centimeters long. And then, so when we build it, when we construct it, we're going to construct it as close as possible to these dimensions. The fins will be exactly as advertised here, so will the thickness of the actual rocket tube, and nose cone as well. We'll get that as close as possible. And once we've built it, we will just rejig the numbers slightly, and then we'll re-examine the position of the center of pressure, noting that it shouldn't change more than a centimeter either side of where it is right now.
So when it comes to gluing the cans together, what I'm going to do is I'm going to use a little rig to help place the cans on top of it like that, and the intent is to glue the bottom rim with each bottom rim and the top rim with every other top rim like that, and we'll use super glue to slowly fill in the gaps, and we'll just repeat the process over and over again until we get a really good solid bond. It may not sound very strong, but all of my rockets that have used cans like this have all been secured with super glue. So you slowly drill it, just grasping it firmly, but not too firmly you won't crush the can. And then gently with the saw hole, apply a little bit of pressure. Take your time with this. You might need a few extra spare cans. There you go. And when you're gripping it, don't grip it from here, grip it from close to the rim itself, because that's the strongest part, but not too firm, so that you don't crush it. And apply a little bit of pressure from the drill. I want to try and drill holes on either side of this can. That way, when the ejection charge comes through, it punches through all the different cans, and it can propel both the payload and the recovery system out of the rocket. And now the back's done, we'll try and do the front. Now the other side is a little bit tricky. You can choose to use the hole saw if you want, but there is an alternate way which takes a little bit longer, but it's a little bit safer in that you don't risk damaging the entire can. So you get your snippers and just cut just a little bit from the edge there, and then grip it with the snippers, and then slowly peel it out. It's like that. It doesn't look very tidy, but all that's going to be tucked away on the inside, so you're not going to be able to see it anyway. We're just trying to make just enough hole so that the ejection charge can punch through unobstructed. That way you get maximum benefit from the ejection charge rather than have it been slowed down by smaller holes. Very gently. You can widen it by taking a snip and then using the pliers, and that should be more than enough. So in this can is where the rocket motor is going to go. So the rocket motor is going to fit in here, and then the ejection charge is going to punch through the top here. So we're going to remove this entire rim here just using a can opener. And what we're going to do is I'm going to put a piece of paper, wrap it around, line that up so it's perfectly perpendicular to the center line, and then draw a mark and then cut that out so I have a perfectly perpendicular cut. And we wrap the piece of paper around so it overlaps, and if it overlaps perfectly you should not be able to see either layer. And you push it up, and just with a felt tip marker mark out the outliner, mark out the line, and then we'll use scissors just to cut it out. Be very careful here because this is sharp and you're at risk of cutting yourself, so just take your time with this. Be very careful and start by cutting the rim and slowly working your way close to the line. Like I said, take your time with this. And once that's done, I recommend you give it a good wash just to get all the cutaways and the debris caused from the saw and the cutting. And it's cut. Nice and straight. So I'll put 2 planks of wood here and they're separated by 3 batteries each so you can maintain the consistency of the separation throughout. And we'll start with the outer edge first. Place it like that. We'll start with the next can. We're going to glue this part here to that part there. And all you do is you just bring them in till they make contact and just apply just a few drops of glue and just watch them as they flow down to the edge. As you can see now, it's pretty good. So I really want to show you the actual strength involved with super gluing the cans in this arrangement. So it's got really good compression strength, and you actually try and tug on them here. It's actually got a bit of tensile strength as well. And just to demonstrate it, put it like that. You put a 1 kilogram mass on it like that, no problem at all. And you can also demonstrate the tensile strength by hanging that same weight off it. No problem at all, so it can handle it. I've had a lot of success with these, with this particular design. So for the cutting of the fins, I cut out the template from the printout, and I'm going to transfer the template onto this piece of balsa wood, noting I've drawn the direction which the grains have to go in. That way it provides maximum strength for the actual fin itself. I'm going to be using 3mm balsa wood. Now the best way to transfer it is to simply just mark out the corners and then just use a ruler join them. That way you have your edges as straight as possible. And there's the 4 fins complete. Now you can sand these down if you want to make them as even as possible, but that's pretty good. I'm really happy with that. And then from here on I'll show you how we're going to glue it onto the actual body itself. Now the next part of this project involves gluing the fins onto the body itself. So what I've done earlier on is I've actually prepared just a drawing, an alignment drawing. The circle is the exact same, it has diameter of the actual body itself. And what I do is I'm going to put the body, line it up with the center there, and then use the alignment lines to carefully line up the fin and then glue it onto the body itself. Now I'm going to use this battery here because I know it's exactly 90 degrees. I've squared it off earlier on, and use it to assist me in the alignment of the fins. I also want it to be 1 centimeter from the actual bottom of the body itself, so I'll use that as a guide whilst using the battery itself to try and get as square as possible. So it's very important to align it like that, and then you just need to tackle it for now, so you can apply just a few drops. And just give it a couple of seconds, and you're almost ready by then. And once that's ready, just repeat the same process with the other side. No, stop it! Hey! So once you finish gluing the fins, it won't hurt to go over the seams with several layers of super glue, just to make sure you create a really strong seal between the fin and the cans themselves. And at this stage it's looking pretty strong. That little wiggle there, you see, that's just the can deforming. Once the engine and the engine mount are secure inside, they'll actually stiffen up the body and the fins won't move at all. And just to give it a quick tug down the leading edge, just to make sure it's not going to come off. Make sure the seams have all been covered up with super glue. If you're not comfortable, feel free to use a little bit of epoxy glue just to fill the seams, but I was able to fill the seams really well with super glue, and I'm pretty happy with this result. All of my rockets that are built out of aluminium cans use super glue for the fins, and I've never had an issue. So from here, what we'll do is we're going to build the payload bay, which is essentially just a hollow cardboard tube or a plastic tube, which will carry the payload electronics and the recovery system, which is just a parachute. We can build out of 2 materials, either clear plastic, and we'll just wrap it round to form a tube as such, or we can use cardboard. For the purpose of this exercise, we'll be making it out of plastic. That way you can see inside. Once the payload bay is complete, we'll make the payload electronics and then build the nose cone, and then we can work on the recovery system. And it might be a good idea just to sand down any residue super glue that's just leaked its way to the body. You want the body to be as smooth as possible. That way you can allow the paint to create a really smooth layer, but also to help facilitate the next step. I wouldn't stress too much about sanding down the seams where you applied super glue between the rocket joints. Just focus on the actual body itself. Now, to make the actual payload bay itself, it's a plastic sheet about 0.5mm thick. It is pretty strong, and I'm going to wrap it around at least 2 of the aluminium cans, because I want the sheet to overlap precisely parallel. So once I've wrapped it like that, I can then go ahead and get some tape and just tape it across from end to end. Or if you really want to, you can apply some super glue across the length of it, like that, and then applying equal force down the length of the strip. Just hold it down and wait for it to dry. Now some super glue might escape from the seams and be caught onto your skin, so just watch out for that. As you can see, that's complete, so we just move it up like that, and you can adjust the length of the payload bay as required to match the length of the rocket itself. So from here you get a good appreciation of what the approximate length of the rocket is. We've just finished the payload bay. We can do a little bit more work to reinforce it, but it's just effectively a plastic tube now. It is pretty strong. This can be adjusted as required to make the payload bay as big or as small as you want. We're going to keep it roughly there, that way to allow us roughly a can and a half. The can, payload electronics will be roughly the size of the can, and we're just going to leave some area here for the recovery system. Feel free to put some tape across the seam to reinforce it. And at a later stage, we're probably going to tape the payload bay onto the can itself. You can glue it if you want to, but if you glue it, you run the risk of being unable to manage it towards the end if you want to move it and make little adjustments. If you tape it, you can always remove the tape. Now, I won't tape it just yet. We just want to see, we just want to examine our painting arrangements first. But for now, we have a pretty decent payload bay. And we can put that there if you want, just so you can keep it stiff for the time being. And this could be roughly the size of the body. So there's a payload bay there with the nose cone and the recovery section. So for the base and tripod itself, I'm going to use the wooden base with 3 pieces of wood like that, and I'm going to cut out 3 additional triangular shaped legs, and these will bolt onto the side like there. That way we have a tripod with the 3 very strong legs, and then so I'll just go ahead and cut those pieces of wood to shape and cut out these leg templates as well. Right, so now we've got the pieces cut. You can sand these down just to make them a bit more smooth, but these are the main pieces. These are the 3 legs, and we have the base, and we have the 3 bits of wood. What I'm going to do is I'm going to glue them and then screw them in like that, 120 degrees apart, and then what we'll do is we'll screw these in as well. You can choose to use bolts and nuts if you want them removable, if you want them to be removable. However, in this case, we'll just make it a permanent base. So from here, we'll just draw 3 lines that are 120 degrees apart. And we'll start with drawing just a single line from the center down to the edge, and using a protractor and measuring out 120 degrees. Hole there. Now all we've got to do is drill 2 holes from each end there so you can secure these to the base. Now it's all done. We can actually mount the tripod legs on each one of the planks there, like that. So as you can see, the tripod is actually complete. It's pretty sturdy. Remember, it's not going to be carrying a lot of weight. Legs have been secure with 1 screw. They won't go anywhere there because the tip of that will bump into the base itself. And all that's left from here is to build the actual launch rail and the deflection plate. But this here will be more than enough to carry the weight of the rocket we're going to be launching. So last time we finished the actual tripod base, what we're going to do now is build or install the actual launch rail guide. Now I took this from an earlier project. All it is just a strip of 2 centimeter pine, and I cut out a semicircle of 20mm MDF, glued it and secured it onto the pine wood. And then all I'm going to do from here is secure this onto the base using a hole, nuts and bolts, and a wing nut. That way it will enable me to rotate the actual rocket around depending where the wind's coming from. Now on top of that as well, I've included several marking holes, and these allow me to tilt the actual launch rail depending which way the wind is coming from. So ideally, if there's no wind, you'll launch a rocket straight up. If there's a little bit of wind, you want to launch away from wind. And these alignment holes here will allow you to tilt it away from wind accordingly. For the launch rail itself, I used a 7mm steel rod from the hardware store, and then I mounted onto once again another piece of wood, pine wood. You just drill a hole inside of it and just jam it in. And how this is going to be used is the center of this launch rail will sit through there, and I'll secure that with a nut and a long screw, and then another screw will go in here and secure the top of the mount to the top of the semicircle. That way I can adjust the angle accordingly. So ideally you want to launch it straight up. However, if there's any wind, you need to launch it away from wind, and this will allow me to tilt it at the appropriate angle. There's only 4 settings. It should be more than enough. And if you're wondering why it is actually offset, that's because if you do tilt the rocket away from its base, it will have a moment. And if you want to get a better look at it, there's what it looks like there. Just a semicircle, 20mm thick, and it's glued and then with screwed, it's secured onto the pine strip, like that. It's got a hole here in the middle. This will be the anchor point for the launch rail, and these are different angle settings. You can set those to anything you want, but I reckon do them at 10-degree intervals to be more than enough. For the launch rail, it's a long, thin steel rod, and then I jammed it into another small piece of pine with a hole there which will go through the center, and then another hole there for the different angle settings. Now to put the mount onto the base, I'm just going to screw a hole about 5mm wide, and just using a nut and a long screw. Just like that. So, the ideal positioning will be off center, like that. That way, if the rocket's launching straight up, then all the mass is going to be distributed along the 2 legs here as well. And alternatively, if you tilt the rocket in this direction there, or away from wind, then the center of mass will be sitting directly over the center. Otherwise, it is pretty stable. Now, for the launch rail itself, as a tip, once you mark out the center and you mark out the setting hole here, make sure it is the same distance as the distance between that hole there and each one of these holes, because it's rotating around the circle like that. Use a long screw to secure that in. And this one's a little bit tight, but it's okay. And that is secure right there in the vertical position. Now, to make sure this doesn't tilt or move, then you're just going to put the screw through there. That way you know as if you're not going to move. And you can either tilt it, and secure the top part, that way it's not going to move. And there you have a launch rail tilted appropriately for the wind conditions. This will be my Deflector Shield, and because I cut down the actual rim itself, there's revealed almost no sharp piece whatsoever. Even if there are some, I can just sand them down with a file. This will be used as a deflection shield. Next thing I really want to do is prepare the deflection plate for mounting onto the launch rail. So for that I've got a 2x2 by 8 centimeter piece of wood. All I'm going to do is mount it onto the deflection plate and drill a hole through it, which is slightly larger than the launch rail itself. And I'll secure the wood onto the actual deflection plate using just 2 small screws. Alright, now I've created a way to build a deflection plate and put it down the launch rail itself. And there's the deflection plate on the launch rail. That way when the rocket engine burns, it spits out all the hot gases and all the other debris and gunpowder onto the plate and doesn't actually burn the remainder of the mount. You would get some residue and some gunpowder spillover, but it won't be the really hot exhaust gases. And just to give you some perspective, that is the actual launch base with the mount and the launch rail. The launch rail itself is about 1.2 meters long. Now for the actual payload bay, I decided I'm going to use one of these free Red Bull cans as a payload bay. What I can do is I'm going to cut a very small compartment there where I can slot my electronics and use just a little bit of tape to make sure they don't go anywhere, and then cover that up. And then what I'm going to do is I'm going to tie a little anchor point here, which will tie to the recovery system, which is the parachute itself, and the shock cord. That way it'll make it very easy for me just to build the cone and mount it onto the payload bay. That way the payload bay and the cone that way the payload bay and the nose cone are just a single continuous piece. The cone itself is going to be made out of cardboard. I use old plastic wine glasses with the sharp tip, but they don't sell those anymore in the shops for some reason, for obvious reasons. So I'll be building the cone out of cardboard. We're going to build the cone as close as possible to the design spec. It is not hard. You just get a thin piece of cardboard, roll it up and glue it on, and just try and center it as much as possible. And I'll show you how to do that. Like this. That's roughly the cone I want. And then you get a rough idea where the can fits inside. So that's a little bit too short. So just tighten it just a little bit there. And the beauty of this is the length of the cone will actually slightly affect the location of the center of pressure. But if you're changing 1-2 centimeters here and there, it's not going to make much of a difference. And the beauty of this is you can go back and readjust the cone length on the simulation software to get your final position of the center of pressure. In this case here, you can, if you want to, choose to 3D print the cone. However, the entirety of this video is dedicated to people who want to build stuff purely from scratch. That way you have a really good appreciation of the complexities and difficulties, and you can make your own adjustments along the way. So just a little bit of glue there, starting from the top of the nose cone and slowly working your way down to the base of the cone. Now you can, if you want to, choose to put payload in the cone itself. That'll be up to you though. For the purpose of this demonstration, the cone will remain empty. Noting that the compartment directly underneath will have all the electronics. When putting on tape, try and squeeze out as much of the bubbles as possible. That way so you can try and make a smooth surface. And you can see we're getting a little bit closer. And that'll help us refine our trimming process. And we're going to cut roughly, so there's my dots right there. If you really want to, you can try and center it as best as possible, and then just follow the indentation caused by the can. We'll make small adjustments to this, because you want to make sure the cone is as centered as much as possible. So now that we're happy, we've glued most of the strips in, I'm going to apply just a little bit of tape just so I can tighten the remainder of the loose tabs. And there we go. There's the payload bay. Make sure when you put it in, it's not really tight, otherwise the ejection charge is going to have trouble pushing it out. Have it as it is now, it is pretty snug. It's not loose, but it's not too hard either to pop out. The recovery system will go there, and then next we'll show you how to make the engine mount. And there's just an overall progress of the actual rocket itself. So the fins are complete, the nose cone is complete. Now we can go ahead and measure the length of that nose cone and modify the simulation software. We're going to be using a single can as a payload bay. I'll show you how we're going to slightly modify that so it can house some electronics. Next we're going to do is get the recovery system and apply some wadding to the insides of the can. That way the recovery system does not burn through as the ejection charge punches through. From here we're also going to need to mount the launch lug, which will allow it to slide across the rail. Launch lug. I'm going to use a piece of paper. I'm going to wrap it around this garden irrigation tube, which is 7mm. The launch rail itself is 7mm, so I'm going to use this and wrap it around to make effectively a tube, and loosen it just a little bit. That way it'll fit over the launch rail itself, but not be too tight. So for the launch lug itself, the launch lug there and the launch tube like that. And what I'll do is I'm going to glue it. I'm going to secure it such that it is in between the fins there. That way the rail can go in between, and I'll line it up as best as possible. So let's do that now.